Hello, everybody. Hope everybody's doing well, safe, and at home. And we're going to do some different things here involving three-dimensional shapes, actually. We're going to look at today in this section prisms and cylinders. I'll explain what those are. At a later time, we'll look at pyramids and cones, and then spheres. I would say this whole section's pretty easy, what I would usually call plug and chug, meaning I'm going to give you formulas and you just plug in the values and chug along and get the answers, okay? A couple little definition terms here in the beginning, nothing major though, okay? Nothing I'm really holding you to. I just want you to kind of find the answers to things, okay? First of all, we're going to talk about a prism. Well, what is a prism? Well, fancy term is it's a polyhedron. A polyhedron is anything that encloses a space that's made of polygons. So any three-dimensional shape is called a polyhedron. We're not going to worry about that. But a prism in particular has two congruent bases, and typically we see them on top and bottom, but they don't have to be. And they're going to be parallel to each other, those bases are. As you can see right here is the base that we're talking about, and then there would be another one down here that we can't quite see, but it'd be the same shape. In this case, either a rectangle or parallelogram. A little hard to tell from this shape here. There are lateral faces or lateral sides. Those are on the outside, and for a prism, those will always be rectangles. This base that you see up above here can change. Different shapes. We can deal with triangles and rectangles and squares. That's typically what we'll deal with. But the sides will still be rectangles. Okay. So there's a couple formulas. We're going to talk about two things. One is surface area and volume. How to keep the difference there. Surface area we typically think of as the skin, the outside. I like to think about it. If this was a box I was going to put in wrapping paper, how much wrapping paper would I need? How much area? So it'll be like square inches, square feet. So it's the outside, whereas the volume is the inside. How much space does it take up? Okay, how much would it hold? And we think of that in units in terms of cubed to the third power, so feet to the third, meters to the third, inches cubed, that kind of thing. Okay, so let's start off here with surface area of a prism. Oh, before we deal with that, prisms can actually be talked about in two different ways. We're only going to deal with them in one. They can be what's called oblique. Or right. We are only going to deal with right prisms. So you may see that term in some of the work we're going to do. Right prisms mean that the sides are perpendicular with the bases. They're kind of straight up and down. Oblique, they would not have to be. In other words, if I had some base here, that looked like this shape, and then up above, the shape would be the same, the exact same base, an oblique one would be at some weird distorted angle like that. That might not be the best drawing, but you get the idea here compared to the previous one here, how it's straight up and down. Okay? All right. So we're going to deal with right prisms. All right. So here's the surface area formula. You might want to take a minute and copy this down. I also will include a little formula sheet with each of these units, but you might want to take a minute and copy this down along with what each letter means. Okay, B is equal to the area of the base. It's going to be a capital B. Capital P is going to be perimeter of the base, and H is the height. So this works for no matter what shape we're dealing with. We'll see that. And so we use this formula, 2B plus PH. Okay, so let's look at an example here. We'll do a couple examples of each. So again, our formula, a lot of times I just abbreviate SA, is 2B plus pH. Well, we need to find those two items first, so maybe I'll do it off here. So we're going to find the area of the base and the perimeter of the base. Well, here's our base. Okay, it's a rectangle with sides of 4 and 3, not necessarily drawn to scale there. That's okay. What we need is understand is a rectangle here. How do we find the area of that? Well, you're going to go 4 times 3. Okay. So that means my B is 12. We'll worry about the units at the end. All right. Perimeter, you're going to add up all the sides. Well, if this one's 3, this one's 3, and this one's 4. So we're going to add up, 4 plus 3 plus 4 plus 3. Okay. And so what does that give us? 14? Yeah, 14 is my perimeter. Okay. Now, the other thing we need to know is this h. Well, we can see that right there is my h, the 11 meters. Okay, that distance there. So all I do is then just plug in. So really the only work is finding that area and perimeter. And so then it becomes 2 times 12 plus 14 times 11. Okay, and so then we just work that out. This is 24 plus this is 154, and then we add those together. We get 178, and our units are meters, and surface area, it's an area, is squared. So my surface area is 178 meters squared. You can type this into most calculators just as is. You don't have to break it up in parts like this and do that, but you could type it all in one shot. All right, so pretty simple. All right, so next is the volume. Volume is, the idea is the space it contains. Notice the units are units cubed. Okay, and our formula is just volume equals base times height. Now it's area base. Okay, same B, same H, same letters. All right, take a minute and copy that down. If you have to pause it, pause the video. That's the other thing you want to do. All right, okay, so we're going to use this one. It's the exact same thing, right? So we need the B. Well, we already did that in the last problem, right? It's 4 times 3 is 12. Okay, this is my H, and volume is B times H. Well, that's going to be 12 times 11. So real simple in this case. That's 132 meters, in this case, cubed. All right, so hopefully you can kind of see, and a lot of times we'll ask you to do both for the shape because it's, you know, you're doing some of the same information here, you're just plugging in, okay? All right, so let's do both here for this one. This one's a little different. Now, this is a rectangular, or this is not a rectangular, this is a triangular prism. So the base is a triangle. See the base over here, okay, and this side, the 8, 8, and 5, and then this is 4. Okay, that's the height of our triangle. Now, this is a little bit trickier. So we are going to find the surface area. Let's zoom this in a little bit more. We're going to find the surface area, which is 2b plus pH, and then we'll find the volume, which is b times h. So, a couple things we need. We need the b first. Well, we're going to use this triangle. So the triangle, remember the area is 1/2. Oops, let me write it up here. Triangle area. Area of a triangle equals 1/2 base times height. Now that's a different base. We're talking the base of the triangle. So we're only looking at this triangle here, just this triangle here. All right, so that's 1/2. Well, what's the base of that triangle? Well, it's this. It's 5 times 5. And what's the height of that triangle? Well, that right there, 4. Okay, so it's a little confusing here. You have to kind of take a step back and go, okay, I'm dealing with just the triangle. How do I find the area of that triangle? 1/2 base times height. Well, that's my base. That's my height. So then I'm going to plug in. This gives me 10 for my area. Okay? All right. Now, we have to find the perimeter of my base. Remember that P... This P is perimeter of the base up here, this right here. Well, what is the base? Well, the base is a triangle with sides of 8 plus 8 plus 5. So that means my P is 21. Okay? All right. We have everything we need except for one more thing. The H. What's the H? Well, the H is this. Okay? The H is the height of the prism. In this case, the prism is laying on its side, so really the height is the distance between the two bases. Remember, you can't see it, but back here, right, there's the other triangle. There's the other base back here, right, in that area. And so the height is the distance in between those two bases. So my H is 10 that we're going to use in our formula. Don't get it confused with the H in the triangle, okay? A little bit tricky there when we deal with a triangle. So 2 times my B of 10 plus my perimeter of 21 times 10. What do we get here? We get 20 plus 210 is going to give me 230, and we're dealing with an area, surface area, so inches squared. So there's my surface area. Volume is a lot simpler. Oops, I started using the perimeter. It's going to be 10 times 10. Okay, so the volume is 100 inches cubed. Okay, all right, so surface area and volume. I'm going to give you a couple problems on a worksheet that I've submitted here to deal with those. Basically, I either deal with rectangular or square bases or triangular ones. All right, so what's a cylinder? Okay, well, let's take a look here. A cylinder, if you notice, I put a picture of a soda can. All right, the cylinder is kind of like a prism with circular bases. Okay, it's got a circle at the top, a circle at the bottom, and then the lateral side there. All right, so we're going to deal with cylinders here. Okay. Very similar plug and chug. These are easier than prisms because you don't have to worry about like finding different bases. Truthfully, I have all this stuff here about lateral area and base area. Really, all I want you to do is jump down here to the formula: 2 pi RH plus 2 pi r squared. R is the radius and H is the height. Okay, that's all you really need to know. You might want to pause that to write that down. This is really simple because I'm only going to give you an R and H. The only way I confuse you is if instead of I give you the radius, I give you the diameter. Okay, so let's look at these couple examples and kind of move on here. It says find the surface area of a cylinder that has a height of 3 inches and a diameter of 6 inches. Okay, so here's our formula for surface area again. 2 pi r H plus 2 pi r squared. Well, I need to know two things, my r and my h. Well, the h is 3 inches. The r, well, they don't tell me the radius, they give me the diameter. Okay, well, so what's the diameter? 6. What's the radius? Half of that. So the radius is going to be 6 divided by 2, which equals 3 inches. And then we just plug into our formula: 2 times pi times 3 and times 3 of the height plus 2 times pi times 3 squared. Now, you can type this all in one shot. You can do a couple other things. We can multiply here the 2, the 3, and the 3, and that gets me 18 pi. Plus over here, going to get me the same answer because 3 squared is 9 times 2 is 18 pi. Which, and I could add those together and get 36 pi, and then 36 times, you can use the pi button, or you can do 3.14. We could have done that up here even and plugged it in there. Okay, either way, let me confirm that on my calculator. You should get 113 point. I have 0.04 or 0.09. It depends on what you use. I'm going to say 113.04, and that'll be in inches squared. Okay, so it's a real plug and chug type of thing. Again, you don't have to do like I did and get 18 pi plus 18 pi. You could type this in one shot on your calculator. Okay, so the only other thing is a volume problem. All right, so volume, the real important thing here is this is the formula. That's all you need to know. And again, R is the radius, right? And H is the height. Same exact thing. These are definite plug and chug. That's why I'm kind of going through these ones quicker because these are pretty simple and straightforward. All right, so again, you could have paused that or go back to get that formula. Same exact problem here. I chose, so we got pi r squared h, but we already know our r is 3 for this case, and our height is 3 because, again, they gave us the diameter, so we're going to take half of that. Again, if you did it in terms of pi like I did in the last one, 3 squared is 9, times 3 is 27 pi. If I type that in a calculator, I'm going to do it here just to confirm my answer. Oops, wrong thing. And 84.78-ish. But it is in terms of inches cubed. All right. Okay, hopefully that makes sense. I'm going to assign a worksheet here with some problems in the assignment section, but that's it for the notes. Okay, take care.